Okay. Let's just step back through. So I've got my functions up here. I have main, which is just a nice way of breaking this into pieces. And then I have my pieces. In the first one, I add 100 each day for 20 days. In the second one, I double it each day for 20 days. And I have the extra complexity of having to track it in cents versus dollars. And so I have this little function here. You can see how even with a small problem, all the parts fitting together kind of get away from you. So again, that's why I say if you're like, wow, I can't get this working, and you just did it in pennies, fine. That's totally fine. I could live with that. But this just looks nice, so I'm kind of putting this version up. All right, so I'm going to run this and see how this looks. All right, so solving the first part, so I get up to $2,000. So on the total at the end of the day, I get $21,000. Pretty good deal. Okay, now solving the second problem. On the last day, day 20, I make $2,000. Here on day 19, I make 2,600, and on day 20, I make 5,200. So 10,000. So you see here, even though I start making more money per day, because it's getting bigger, I started off so small. My total pay here is 10,000. So still a better deal to take the $100 a day. So now we're going to try 30 days. Which is the problem we want to solve for if I want to go 30 days. All right, so I'm going to run this now and scroll up to see the top. So on my 30th day, I make 3,000 with the original deal, so 46,500, pretty good. Let's scroll down and look at this, and I see by day 30th, I make so much money it won't fit in a double. And I can already see here, my total pay was 46,000, and I'm making more than that a week ahead of time. Okay. So, that's pretty good. And again, the point of that, if I were to go back to the graphing calculator that I was kind of showing in my references, is because the curves move at different rates for linear growth versus exponential growth. Just show you that again real quick to remind you kind of what I was talking about. Ooh, this looks terrible in dark mode. Pardon me. Okay, great. And it's going to be too hard to see on my screen, so I'll just say y equals x. Right. So there's my sort of every day I make a certain amount more. That's a linear curve. Whereas here I say let's do y equals doubling it means I get 2 to the x. Okay. Well, now this looks, obviously this curve gets much higher. But this one is in dollars and this one's in pennies. So let's try times 0.01. Well, now this looks interesting. So this is, and actually here, let me actually do the math right. So I'll say 100 times x, right? So this is every day you get $100, and this is you start with a penny. So really not much. It takes you a long time even to get $1. Okay, so you're like, wow, that looks like, looks like the $100 there looks like a better deal. But when I zoom out, oh, I'm doing my graph wrong. Yeah, what you're going to see is at a certain point, I'm going up way faster, even only getting starting at a penny, going a double each day. And I'd have to scroll way back down to find out where they meet. That gets kind of confusing, right? So let me just show you what it looks like with y equals x versus this. I want to reset this to. Okay, let me just. It's easier just to go back to the beginning. my nice linear curve and my curve which is exponential but starts very small. Okay. So it's a little easier to read in the example of do you want to make $1 a day or do you want to start with a penny and double that every day? So I'll show you that curve. So here you get $1 extra every day. Here you double, and you see that curve. Okay. So again, not to get too topical, when you see people going, why are people freaking out over only X number of cases of a topical virus, a popular virus that's been talked about a lot? Well, because the exponential curve means you could start with a certain number, and then the next day you have as many people that were infected that day as been infected in the entire previous history that you've been tracking. So when people talk about flattening the curve, what they want this to do is to go back down. How does it go back down? Well, we could do something like, what if I want to subtract people, like say maybe every day. Oh, that's going to be a little hard to see. Never mind. I have my graph here. Let me just fix this. The idea is the curve goes down because people get better or they are no longer with us. So you're not tracking, like the curve of number of people infected total will always keep going up sort of without limit until people have immunity. But what you want to look at is the number of people who are currently infected. And so then you get what's a nice little bell curve where it comes back down. And so the reason you want to flatten the curve is because, let's say here's the number of hospital beds you have. You really don't want to go above that line. Yeah, exactly. That's probably the way to do it. So let me fiddle around with the graph a little more to get a good curve of what that looks like. Um, yeah. This was never my strong suit, right? So I'm kind of faking it. But the way the curve would work, yeah, it's going to have a nice bell curve is going to go on the other side. So what would that look like? So if I say, let's look at it. What does a log curve look like? Let's say if I look at how much a log of x. Yeah, nice, good eye. Thank you. Ignore the fact that this curve starts below zero because this is not this is just a logarithmic curve. Okay, so let's do another curve here to show y equals 2 to the x. Cool. All right. So what you can kind of see is an exponential curve goes up and up and up and up. A logarithmic curve does the opposite. A logarithmic curve will get sort of a kick to it, and then it's going to slow down. It's going to increase fairly gradually. So now as you see, what you'd like to see is something like a log curve coming up and then going back down. And those are just the types of curves. Now, again, you don't really have to understand how all this fits into mathematics to be able to do the problem, but I just wanted to give you some background as to what's going on with it. Now I have the separate issue of, wow, I'm running out of space here. This is bad. How am I going to do that? So, what I'm going to do for now, I'm going to cheat, and I'm going to say, let's do 25 days. Is this a case of me modifying the problem to make it easier to deal with? Yes, and that's shameful. But all kidding aside, it's going to be easier to read that way. So my total pay for 25 days is $32,000 the first way. And my total pay for doing it the other way, let's do that math again, $32,500. So I'm making 10 times as much using the doubling method. And if I add 1 day, well, I'm going to make as much again, right? Because the next day I get paid, this gets doubled. So it's going to double. So let me actually show you how that looks, right? So if I say, what if I do day 26? That's 671,000 instead of 303,000. So you see that doubling really adds up. And so it's a case of when that matches. All right, so for the sake of the video later, I'm going to do a quick scroll or a slow scroll through the code so that, if you're trying to recreate this at home, you can kind of look at what I've got and hopefully see what's going on here. So I've got the section where I declare. I've got my nice main. Again, there's many ways you could do this. So feel free to try your own way. This is just, I would say this is not even particularly well designed. I just tried to create it myself. So here's my function for part 1. Looks good. Here is my function for part 2. And here's that utility function I use. All right, so now I'm going to save that